In this lesson, we're going to expound on what we just learned yesterday with what happens when the lines are parallel. So let's just start with our warm-up. Fill in the blanks with sometimes, always, never. Alternate interior angles are. Well, alternate interior angles, how often? So alternate interior angles are congruent. Can alternate interior angles be congruent? Yes, absolutely, if the lines are parallel. But if lines are parallel, right, alternate interior angles are congruent. But you can have alternate interior angles and they're not congruent if the lines are parallel. So sometimes alternate interior angles are congruent. Sometimes they just are there. It's just location. Remember, being in alternate interior angles, that's just location. It's not a relationship until the lines are parallel. Same side interior angles are congruent. So same side interior, remember that same side interior angles were supplementary if the lines were parallel. They don't have any relationship necessarily if the lines are not parallel. We don't know what that relationship would be. Now, can they be congruent? Yes, there's one situation where they can be congruent. If the lines are parallel and they are perpendicular, then those two are congruent to each other, because then that is the only way that they can be congruent to each other and still add up to the 180 that they need to. So yes, they can be, not very often, but they can be congruent. But most of the time, they are just supplementary. Okay, we don't see them be congruent very often on a standard. They're not standard that way. Same side interior angles of parallel lines are, so in this case I said of parallel lines, I didn't mention before that they were. So same side interior angles of parallel lines are complementary. Okay, so complementary is our operative word, and they are never complementary because they are always supplementary, not complementary. Complementary means they add to 90, supplementary means they add to 180. Corresponding angles of parallel lines, again we've got that of parallel lines. Corresponding angles of parallel lines are always congruent. If lines are parallel, then corresponding angles are congruent. Because I said they're parallel, then the answer is always. Versus this one up here, I didn't mention anything about being parallel. They can be parallel, but they don't have to be. Vertical angles are always congruent. That is by definition. Vertical angles are congruent angles that share a vertex, that do not share a side. Now, we're going to do these problems that we did yesterday. So remember, we said if lines are parallel, then corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. And same side interior angles are supplementary. So the first thing that you have to do when you're going to decide how to set these up is you have to decide what kind of angle pairs are they. So if these lines are parallel, M is parallel to N. So here is my parallel lines, and then I have my transversal. So my transversal is right here. It's the line that cuts across those other two lines. Now notice that the two angles that I gave you, the 5x minus 8 and the 3x plus 6, they are on alternating sides of the green line. They are interior, they are inside, in between the yellow lines. So they are alternate interior angles. Alternate interior angles. If the lines are parallel, which they are, it says that they are, then alternate interior angles are congruent or equal to each other. So you would set this up by saying part equals part. 5x minus 8 equals 3x plus 6. From here, it's all algebra. Okay, if we drop our line down so we can keep our sides separate, you want to go ahead and isolate your variables. So we're going to move our 3x over to the other side. Do this in steps. 2x minus 8 is equal to 6. That positive 6 just becomes a 6. Then minus 8, you would add 8 to both sides to make that minus 8 cancel out. You're left with 2x is equal to 14. Then it's 2 times x is 14, so you do the inverse of division, and you get that x is equal to 7. So to solve for x, x is equal to 7. And I could have, if I had asked for it, I could have said, then find how big each of these angles is, and you could have found that out. That would have been 21 plus 6. which is 27. Okay, so again, we'll do the same thing here. Notice your two lines are parallel, so that is the important part. Without those lines being parallel, there is no relationship between these two angles. Okay, so I have my transversal that cuts across those two yellow lines. Those two angles, if you notice, they are in, both of them are in the upper right-hand corner of their respective pluses, their respective vertices. Okay, so this 8x plus 5 has its vertex here, the 12x minus 35 has its vertex there, and they are both in the upper right-hand corner of those pluses, and so they are corresponding angles. If the lines are parallel, which I said they were, corresponding angles are congruent, and so this gives us a part equals part problem. So 12x minus 35 is equal to 8x plus 5. Okay, now we're just going to do the algebra. That's the geometry part. Part equals part. Corresponding angles are congruent. So we're going to separate these, get these to the same side. 12x minus 8x is 4x. Minus 35 is equal to, that plus 5 becomes a positive 5. Add 35 to both sides. You get 4x is equal to 40. Do the inverse, 4x is equal to 40, so divide both sides by 4, and you get that x is 10. If I had asked for it, I could have asked you to go up and substitute those in, and you would have had 8 times 10, which is 80, plus 5 is 85, which you would also get the same thing if you did 12 times 10 is 120 minus 35. Either way, they should be congruent. That's what we said they were. Okay, so let's look at number 3. Again, let's highlight our yellow, our parallel lines. We can tell they're parallel because of those symbols right there. And we need our transversal. So our transversal is what connects our two angles together. So in this case, those are our two. Notice they're on the same side of the transversal. They're both in between those parallel lines, which means they are same side interior. Same side interior is same side supplementary. So same side equals 180. So part 6x plus part 4x is equal to 180. Those two angles added together is 180. 6x and 4x combine your like terms. You get 10x equals to 180. Continue solving by doing the inverse. You get x is equal to 18. And I could have gone up and substituted those in if I had asked. You could do 6x, or 6 times 18 is 108, and 4 times 18 is 72. And those two indeed do add up to 180 the way that they're supposed to. Okay? Now, on this one, we have several things going on. We've got S is parallel to T, and we've got M is parallel to N. So we're typically going to look at these two because they're vertical right there together, but notice we don't know the relationship. We have an X and we have a Y. Now they're same side and they're supplementary, but it doesn't help me any because I have an X and I have a Y. So I'm going to look at my other side and see what I've got going on. So I notice that if I connect this angle to this angle, that this is my transversal. If that's my transversal, then I'm going to use these two parallel lines. Okay, so those two parallel lines, so just cover that up. So now it looks familiar to us. Okay, they are on alternating sides of the green line, and they are both exterior. So those are alternate exterior angles. Okay, these are alternate exterior angles, and the rule says that if lines are parallel, then alternate exterior angles are supplementary. Or excuse me, I'm sorry, they're congruent. Okay, so we just set that up. 3x is equal to 96 minus 3x, and we're going to solve that equation. So I'm going to add this 3x to both sides. I know that it might be tempting to move this 3x over there, but then you end up with everything on the right-hand side. We want to separate them so that our variables are on one side and our whole numbers are on the other, our constants. So we have 6x is equal to 96. And then do the inverse, divide 96 by 6, and we get that x is equal to 16. Now, in this case, we do need to actually substitute in that 16. 16 times 3 is 48. So this angle right here is 48 degrees because I need that to find the y value because we were looking for x and y. So now in this case, if I connect these two together, now this is my transversal. Okay, now that red line is my transversal, and these two lines are the parallel lines that I'm dealing with. So now I don't need any of this anymore. Okay, so I cover up all of that and I look at those two angles. They're on the same side of the transversal and they're both interior. That means they are same side interior. Same side interior angles equal 180. They're supplementary. But I know that angle's 48. I don't need the 3x anymore. I need the 48. So I'm going to say 48 plus 4y is equal to 180. So take the 180, subtract the 48. So we're going to subtract 48 from both sides. We get 4y is equal to 132. Do the inverse. 132 divided by 4 is 33. You get that y is 33. So y is 33 and x is 16 in this problem. Okay, but you had to start here because they're the like variables. So you just have to look at what you've got and assess. All of this is true, right? These are still same side. They're just not useful for me to start there. So again, this is just setting up equations. You either have part equals part because they're alternate interior, well, alternate exterior or corresponding, or you have part plus part equals 180 because they are same side interior angles.